Alright, so particles in motion practice. The big key word, the buzzword for today is justification. You have to give me a reason why your answer is the way it is, okay? So there's a because factor, okay? So we're going to talk about this immediately with this example 7. So what I have right here is a position y of t. It's in inches and it's moving along a vertical line between 0 and 7 seconds. So the other one that we saw before was a horizontal back and forth, and I gave you a picture like with that scroll going back and forth left and right on that wire. This is like an up and down kind of movement, just a vertical up or down. So if you notice, one thing to really pay attention to is the description of that function that they're giving you. Is it f prime, or is it the position function, or is it the acceleration function? Okay, so like we were saying, noticing what function is given is your first step. Are you given the position function? Are you given the velocity function? Or are you given the acceleration function? We need to know relationships between the three levels for sure. Okay, so let me go ahead and write this out like a table so that you can see what we're talking about. Alright, so this table is very, very helpful and important because we want to see if f prime is positive, then f of x is increasing. If f prime is negative, then f of x is decreasing. And if f prime is 0, then it's neither increasing nor decreasing, and most likely it's either a constant straight horizontal line or a piece of one, or it could be a relative max or a min. Okay? From that, let's furthermore look at the following things. Let's look at the relationship that exists between f double prime and f prime. So if f double prime is positive, that means f prime is increasing. If f double prime is negative, then this is decreasing. That's f prime is decreasing. And the same things, guys, if f double prime is 0, it's neither increasing nor decreasing, it's constant. Or it's a relative max or min. The last thing that I want to make sure that you understand is this is position, this is velocity, this is acceleration. Okay? And the relationship that occurs between f double prime and f of x is that if it's positive, if f double prime is positive, this is concave up. And concave up means it's part of a smile. If f double prime is negative, then it's concave down. Okay? So for instance, if I had a graph that looked like this, this is a piece of concavity that is up. So this would be a concave up, where f double prime would be positive. This would be concave down because it's part of a frown, and that's saying when f double prime is negative. Okay? If and only if that I'm looking at this function right here as a what function? Position, yeah, as an f of x graph. Okay, go with me? All right. So very, very important on this table for sure. So on what open intervals is the particle moving down? So if the particle is moving down, okay, what would you say it is as far as on this answer? What would be my first interval that the particle is moving down? 2 to 4. And what's the other one that it's moving down? 6 to 7. What's your because? What's your justification? You could say because f of x is decreasing when someone else said it. You could also say because it has a negative slope. So we're in calculus, and for the most part, we're going to say that f of x is decreasing by saying f prime is negative. You with me? And if f prime is negative, that means that sure enough, this is synonymous with f of x decreases. Because of what we said right here. F prime is negative, so f of x is decreasing. Otherwise, moving down. Yes, Evelyn?
If this was on a test, would we have to put y of t instead of f of x?
Yes, if it was on the test and if you put f of x, even if it was on the AP exam, they're going to know what you're talking about. You know what I'm saying? You just have to make sure that you put f of x when it's applicable and f prime of x when it's applicable. But they'll just say that you misspelled y of t. You know what I mean? Any questions? Yes?
So, do we put both? What's in red?
So to me, I would prefer that you do what's in red,
Okay.
and you could just say because f prime is negative.
Okay.
Okay? So you could say it's moving down because f prime is negative. All this other stuff you don't necessarily need, but I'm showing you how it correlates. Okay? Any other questions? And like your quiz today, what I just boxed, I'd want you to put. Okay? Yes?
So it's more important to mention the slope than it is specific as of
Perfect.
f of x.
Perfect. Yes, it's more important to say that f of x is decreasing by mentioning the fact that its f prime is negative. And if I wanted you to say the velocity is increasing, you could show it by putting f double prime as positive. Does that make sense? Okay. Showing that relationship between the one derivative away. So on what open interval or at what times between 0 and 7 is a particle at rest? So guys, moving down, we want f prime to be negative. Particle at rest, we want f prime to be what? 0. So here, that's when I go back and ask myself, is this an f prime graph? No, it's not. But if f prime is 0, what does that say about f of x? It's a slope of 0, right? It's a slope of 0, or it's a horizontal line. It could also be a relative max or min. You with me? Any questions on that? So what would be our first interval that we would show this as? 0 to 2. So 0 to 2, and intervals are going to be open because you're saying in between the points. You're not saying that this is a domain of some sense, okay? So the particle is at rest between 0 and 2. Where else is it f prime of x is equal to 0? So some people are saying 4 and some people are saying 6. And here's what I'll say. If they were smooth and curved, then yes, they would be a nice, we would include them. But because it's a cusp, what's the derivative of a cusp? We don't know it. It's undefined. We cannot do it. So it's not going to be, the cusp is not going to say that it's 0 at 4 and 0 at 6. You with me? So we're going to say because f prime of x is equal to 0. Does that make sense, guys? Yes?
I have a weird random question I just thought of. If the, so this graph is an f of x graph, right?
This is an f of x graph, yes.
So if it was an f prime of x graph, does that mean that the slope would be f double prime, so the f double prime is the slope of the slope?
Yes. So you're always using that relationship between f of x versus f prime, that one derivative step away. And if you're given an f prime of x, just like Gabe said, you're just interpreting it now at f prime and f double prime level. But everything's still the same.
So if f double prime is the slope of the slope.
Yes.
So if it was an f prime graph, would the particle be at rest at all the x-intercepts?
Okay, so this is a good question. You guys are jumping straight through the harder ones, and that's okay. Let's finish this one first, okay? And then we'll get to those. I want to make sure that we understand all pieces, because some people understand, some people still don't understand it out there right now, okay? All right, so at what times between 0 and 7 does the particle change direction. That means f prime is going to change from what to what? Positive to negative, or negative to positive. So that means this is synonymous, if you are understanding this table, this is synonymous as saying f of x is changing from what? Increasing to decreasing. Do we have any that are changing? Increasing to decreasing?
2, 4, and 6.
Increasing to decreasing would be right here, right? Where else is increasing to decreasing? That's it, right? So the other one is decreasing to increasing, which is at 4. So this one's going to be at, that's not an A, at t is equal to what? 4 and 6. The particle changes direction. Because, and you can say this, you can say either that one, or you can say that one. You with me? Ultimately, I want you to get accustomed to using the f prime, because it's that calculus level of interpreting what's going on.
What about t equals 2?
T equals 2 does not change direction. You have to change from increasing to decreasing per se.
Oh, because it's at rest.
It's at rest.
Going in direction. It's
Correct.
not changing.
So this is at rest, and now it's going to decrease and decrease, like between here and here, and then it changes to increase, and then it changes to decrease. So at rest to decrease is not changing directions. You with me? That's a good question. All right, so let's move on. From the same one, during the first 6 seconds, what is a particle's displacement? So displacement is change in what? Position. So during the first 4 seconds, what's my initial time? My initial time? 0. What's my final time? 6. And change in position is the final position minus the initial position. So the final position on this graph would be y of 6 minus y of 0. Y'all with me? So displacement is change in position, otherwise change, in positions. And it's final minus the initial.
Why is it the final second?
Yeah, it's not
Because it says during the first 6 seconds.
Oh, duh.
No worries. So read carefully, please. Okay, so, because they'll do that too, and I have specific times for you guys too on quizzes and tests. So during the first 6 seconds, do the displacement. So what's y of 6, guys? 0. Because again, this is a y graph. So that means go to x is equal to 6 and tell me what the y value is. What is y of 0? 6. So it's going to be 0 minus 6. Bless you. So my displacement is what? Negative 6. That means wherever it started, it moved to the left 6. Or wherever it started, it went down. It fell down 6 feet. Or if I'm driving in a car, I went backwards 6. Left, down, or backwards. Okay? And in this case, because of this vertical line movement, it's moving down. Okay? So you'll say the displacement is negative 6 what? Inches. Okay, during the first 6 seconds, through how many inches does the particle travel? This represents 3 words that we learned last time. What are those 3 words? Total distance traveled. And the total distance traveled means Going forward and backward, account for everything. Let me show you a picture real quick. Let's say that this is the ground. And you're here, Drew. And I asked Drew to walk forward 10 feet. Okay? And then I asked him to walk backwards 15 feet. What is Drew's displacement when he ends up here? -5. Because it's the change from your initial final position minus the initial position. But if I asked him to give me the total distance traveled, what's the total distance traveled? 25. Because you have to account for this first positive change, which is 10, and you're also going to add all of this negative change, negative displacement, but you're absolute valuing each change of direction. Go with me? We did this at the very end of notes last time. So if I'm moving backwards and I absolute value just that backwards piece and I add it to the forward piece, guys, what's my answer again? 25 inches. Well, not for this one. Not for, that was the example that I created. So let's look at this. How many inches does the particle travel? How do we set this up? If we're looking at two different displacements, yes? Okay, so from here to here, do y'all agree? We can do that. We could do what is the position at 0 and 3 and say the final position minus the initial position, oops, is going to be what? 0 minus 6. That's for that first one. Now if we do 3 to what? We could do 3 to 6. You with me? What's the displacement? Well, this one would be y of 6 minus what? Y of 3. 6 is 0. 3 is 0. And then at the very end, what could I do? I could say y of 7 minus y of what? 6. So y of 7 is what? A -3 minus 0. Now watch. Is this correct if I absolute value all of this and say that it traveled 9 inches total? Would that be correct? No, that would not. And nice catch. Because when we do this, we're looking only when it's moving forward and when it's moving backward, right? So looking at this graph, otherwise up and down, it's falling down between 2 and 4. You with me? So it never traveled at 0 to 2. It's staying still. We only want to see the changes in direction. Let's put negative as red. And it's moving forward or it's moving up, right? Or moving to the right, all three different representations, when f prime is positive. So these are the ones that we're going to analyze. These are the ones that we're going to absolute value each individual piece. Okay? So let's go ahead and set this up. It will be this first interval in red of final position. Oops, not 0. But y of what? 4. Y of 4 minus y of what? 2. Okay? Whatever this is, we're going to absolute value it. Okay? And we're going to add it with our second one, which is what? Y of what minus y of what? Y of 6 minus y of what? 4. And we're going to absolute value that. And our last one that we're going to add is the absolute value of what? Oh, it only asked the 6 seconds. Thank you, Gabe. So I don't even have to do this last one. Cool. So y of 4 is -6. Y of 2 is 6. So it's what? -12. So -12 absolute valued, we're saying that it traveled 12 inches. Okay? What is y of 6? Or sorry, yeah, what is y of 6 over here? 0. What is y of 4? Negative 6. So this becomes a positive 6. So when I absolute value it's, oh, not 12, 6. When I absolute value this, it will remain as 6. So my final thing is what? 18 inches total. Hold up just a bit. So 18 inches total. Yes, Gabe?
I just kind of looked at the graph and counted the changes in the y value and got 18 also.
That's okay, but the thing is, it won't always be a graph, so we need to know how to use the math for sure. I could give you an equation. And if I give you an equation, you have to know the initial and the final and set it up as final minus the initial position. And if you have a calculator, you could store that function, remember? And you could just type in what's y of, in this case, y of 4 minus y of 2. Go with me? Okay. F, what is the particle's velocity at 5 seconds? So at 5 seconds, which is here, you tell me, what am I going to analyze to get this velocity? Just the slope of this graph. Because this graph is f of x. Okay? So looking at that, you know that it's on a linear line, and you can say this is 4, negative 6. This is 6, 0. So you could do y2 minus y1 over x2 minus x1. And what do you get? 3. So 3, what? Inches per second. And what does this mean in terms of the movement? If it's a positive 3 inches per second, it's going upward because it's a positive 3. A lot of interpretation for sure. Are we good? Hopefully this graph helped a lot as far as, I know that you guys still have homework and it's due tonight, but it was so that we could finish that stuff today in class. Alright, so now let's move on. This is saying what is the particle's velocity at 5.9999999. So it's basically close to 6. It's right before. Would this be the same answer as the one we got previously? 3. Yeah. What's the part? So this would be 3 inches per second because it's right before you get to 6. How about at 6 seconds? We don't know. We don't know the velocity. It is not 0. Okay? It's just non-differentiable. Okay. So we'll just say does not exist because it's a cusp for the second part. During what open time interval between 0 and 7 is a particle's speed the greatest and velocity the greatest? Okay? So speed the greatest and velocity is the greatest. It definitely has something to do with speed is equal to the absolute value of velocity. First of all, before we get there, I think that one's a harder one. Let's go to I. What is the particle's acceleration at 3? What do y'all suggest that we do? It's the derivative of the velocity, right? So to me, the velocity, all right here, someone said it, is what? It's constant. You with me? And the derivative of any constant, what's the acceleration is going to be 0. And if you don't see that, what I want you to do, a lot of people do this, and that's okay, is that they see that the slope between 0 and 1, or sorry, 0 and 2 is 0. And then they see the slope between 2 and 4. What's the slope between 2 and 4? Negative 6, right? Down 6 over 1. Down 6 over 1. So negative 6 would be like way down here. and that's all the way to 4. Okay? Notice that I have open and open because I'm going to like cusps. Okay? And then from 4 to 6, what's the slope that we said? 3. Because it's up 6 over 2. So it's a slope of 3, so that's going to be way up here at 3. And then this last one, what's the slope? Negative 3. So some people need to, and that's okay if they do. They draw out the f prime like this. And then they look at this and like, let me derive it one more time to do acceleration. All of these are horizontal lines, right? So it'll be like this, look. Horizontal line, still an open, still an open, still an open, and still an open. So that the blue is the acceleration. Does that make sense? Questions? Now, during what open time interval is the particle's speed the greatest? So to me, the speed is the greatest. Let me show you real quick what this is talking about. V of t and A of t. Okay, we're going to graph these out. With me? Alright, so let me show you briefly how to look at this number lines in reference to number lines. Okay. So looking at this graph, I want to know basically when f prime is 0 or does not exist. You with me? So right now I have from 0 all the way to 1, or sorry, to 2. So we could say like 2 and backwards. You all see what I'm doing right now? And then also I'm going to say at 4 and at 6. Please make sure that you have this especially in your notes. If you can understand this, the other stuff is pretty easy. So look at, let's look at the signs on this. Everything to the left of 2 is 0. Between 2 and 4, the slope is what? Negative. Between 4 and 6, the slope is positive. And then 6 on, the slope is negative. You with me? Okay. How about the acceleration? It's 0 everywhere, right? So if it's 0 everywhere, and what were the like critical points where the slope was 0 or undefined did we write for those? We wrote 2. We still wrote 4. You with me? And we wrote 6. But they're all what? 0. You with me? So 0, 0, 0, and 0 as far as the acceleration is concerned. So the acceleration is neither helping nor hurting what's going on right now. So the speed, oops, where's the speed the greatest? So 2 to 4 is the greatest because it's what? A 6. It's the speed is 6, right? So the speed is a positive 6 inches per second. When's the velocity the greatest? Still 2 to 4. Right? And it's because what? Well, we're going to say for velocity, what do we say? Negative 6 inches per second. Do you notice the difference?
It's in its direction.
But if it's asking for the greatest, isn't there a positive velocity which is greater than negative?
Oh, not bad. Yes. Ooh, John. Hey, come come up here. No, I'm joking. All right, so he's absolutely right. He got me. So the velocity is not, my bad, is not the greatest between 2 and 4 because magnitude-wise it's at a those of you who are thinking magnitude steepness, you were right, but it's not the greatest in this sense. It's looking at negative versus positive values. Nice, John. So the positive will be on what interval, John? 4 to 6. And what is it? 3. 3 inches per second because the velocity is the most positive there. Nicely done. Are we good? All right. So now let's look at the difficult ones that you guys were asking about, okay? And I'll probably warm you up with one question before the quiz as far as related rates is concerned. Okay, here we go. Very first thing that you need to do is immediately go to the graph and see what was I just given. So you were just given f prime of x, and now your interpretation is about to be totally different than what you were doing with f of x. But the same relation exists, like Gabe was saying earlier, between the first derivative and f of x, that same relation exists. If f prime is positive, f of x is increasing. Stuff like that. You see what I'm saying? But over here on the other graph, let me show you just real quick. F prime was positive here, and f prime was negative here. Because we were looking at f of x. But if we're now looking at a f prime of x, then we say it's positive when it's what? Above the x-axis, and we say it's negative when it's below. That's huge, guys. And chances are on the AP exam, you're going to get a b of t function. You're going to get the velocity function. Notice the difference. Below the x-axis is negative. Above is positive when you're looking at f prime. Where over here it was negative when it was decreasing and positive when it was increasing. Okay, here we go. On what open interval or at what times is the particle at rest? So I'm thinking already, when is the velocity 0? Yes, Kate?
So you always know what kind of function it is depending on how they label the y-axis?
Yes.
So if it's y, then it's f of x, and then it'll be b for f prime of x.
Good question.
A for...
A would be acceleration, and it's usually with time. V will be velocity, and F or Y, or even like X or S or different letters can be the position. You understand?
No, specifically b for velocity of a.
Well, here's a good thing. Listen, this is a really good question. They could label this as g of x, and they could say g of x represents the velocity. So when they give this to you, this would be like g of x, and they can on purpose say g of x because they want you to interpret, oh, that's position because there's no prime. But down here they'll say it represents the velocity, or it represents the rate of change of this volume. So there's a lot. That's why we spent so much on what we were looking at last class as far as the interpretation of what they gave us. The interpretation of the derivatives.
Honestly, the instruction that under example it shows the velocity.
There you go. Okay. So yes, don't just look at the graph. You'll have to read the directions. Okay. All right. On what open interval? Great questions, guys. Seriously, and nice catch on that, because I want this video awesome. On what open intervals or at what times between 0 and 6 is the particle at rest? We know when f prime is 0. Anyone? What are my values going to be? 1 and 4. So t is equal to 1 comma 4 seconds. Is it seconds? Yep. This is a big one on your quiz today because what? F prime of x is equal to 0. And yes, you could have written v of t is equal to 0. It means the same thing. Okay? On what open intervals is the particle moving to the right? So moving to the right, notice how I'm circling these. What am I going to put as little subnotes? F prime is positive. Otherwise, and you could write it, v of t is positive. Guys, when is v of t positive? 0 to 1, union 4 to 6. Do I put brackets on these? No. So 4 to 6. That's a u. Come on, I know, right? U. On what open interval from 0 to 6 is the particle moving at its greatest speed and at its greatest velocity? We're going to defer to John right now. Okay, so John, the greatest speed on this would be where? At 3? And why do you say that?
Because it's got the greatest absolute, right? The greatest magnitude.
Wouldn't that be? Oh,
Do you see what he's saying? So the velocity is -6. Nice job, John. But the speed is going to be the absolute value of said velocity, which is 6. So the greatest magnitude, i.e. the one furthest away from the x-axis, is going to be that greatest value for speed. We just have to make sure we take the absolute value. Okay, John, what is the greatest velocity?
0 and then 5 to 6.
So at 0, what is the velocity at 0? 4. And so we'll do it like this. At time is equal to 0, and we'll say in between 5 and 6. And you could do this like that, like on that interval. Or if you wanted to write it like this, that is totally acceptable as well. John, what did you say that the velocity was again? 4. 4 feet. Well, what is this asking for? No, it says at what times, right? At what times? Yeah, so you don't need this. So these are seconds. At 0 seconds and 5 to 6. Nicely done. Questions? The last thing that I'll tell you guys, let's go ahead and, so we have two more slides, and then I'll give you a shortcut with speed and increasing and decreasing here in just a bit. On what open intervals between 0 and 6 is the particle's speed increasing? Here we go. This is the big one that they like to ask. And some of you already know the shortcut to this from physics. Okay? Speed will be increasing when f prime and f double prime have what? Have same signs. It will be decreasing when f prime and f double prime what? Have opposite signs. So look at this. We know right now what I'm shading are the signs of f prime. Okay? It's almost like looking at v of t, and this is what I was wanting to show you earlier as well, is 1, 4, I'm positive, then negative, and then back to positive. You with me? If I drew an acceleration graph, here we go. The acceleration is negative all the way from negative or 0 all the way to what? 3. Let me show you. F double prime is negative because F prime is doing what? Not concave. I'm looking at F prime, not F of x. Because F prime is decreasing. Because from 0 all the way to 3, F prime is decreasing, I know my acceleration is negative. Then it's increasing from 3 to 5. So it's going to be what? Positive. And then it's 0 from 5 to 6. So now what I did is I created this as a good reference so that you guys can do the same. At each x-intercept or critical point that we found, whoops, I'm creating these small little vertical lines, and I'm basically going to stack all this information together. So on this first interval, right here, oops, let me do it in gray. The velocity is positive. The acceleration is negative. What's happening? It's slowing down. You with me? Let's do the next one. From this 1 to 3, what's the velocity? Negative. What's the acceleration? Negative. So what is it doing? It's speeding up in the negative direction. You with me? That's when Adam came up at the front of the room and he was walking backwards and I shoved him backwards. He's speeding up backwards. Okay? Let's do the next one. On this interval, the velocity is what? Negative. The acceleration is positive, right? You see that little piece. So what is it doing? Slowing down. I hope this visual helps a lot. From 4 to 5, stack them. You tell me, what is it doing? It's going to be speeding up because right now I have it positive, positive, so it's speeding up. You with me? Now, how about at 5 on? Positive velocity and a what? Zero acceleration. So is it speeding up? No. So not only is it opposite signs, it has to have a sign. Because if it's 0, we know it's not speeding up. You with me? Because velocity and acceleration have to be the same. So guys, this is speeding up. The shortcut is this. When you move away, when you're moving away from the x-axis, it's speeding up. So 1 to 3, it's speeding up. And over here, again, at 4 to 5, it's speeding up. But if you're moving toward the x-axis, what is it doing? Slowing down. And this is only on a f prime graph, otherwise the velocity graph. There's your shortcut to remember. Okay? But again, justification, I don't want you on the quiz or I don't want you on the AP exam to say it's moving away or it's moving toward the x-axis. That's allowable on a physics exam, but not this one. This one you have to say V of t and A of t have the same signs or they have opposite signs. Okay? How do we find the acceleration at 4.8 seconds? Just the slope of the velocity graph, whatever that is. Okay? On what intervals or at what times between 0 and 6 is the acceleration of the particle the greatest? Say again? 3 to 5, because what? Say again? The greatest slope. So the magnitude of it per much, right? And greatest meaning the most positive as well, right? So not only is it the biggest, but it's also the most positive. So the most positive, not necessarily the steepest, but the most positive acceleration is happening between 3 and 5. And what is that? We have what? 3, -6, and 5, 4. So y2 minus y1 over x2 minus x1. What do you get? 5, right? So 5 units. Feet per second squared. What is the particle's displacement during the first 2 seconds? During the first 2 seconds. So, first of all, I'm going to reserve this well, no, I can show you right now. But you won't be quizzed or tested over this yet. You'll be quizzed or tested over this whenever we get to integrals.
Oh,
The displacement of a velocity graph is the area underneath the curve. So this area underneath the curve, when I add those two areas, it will tell me what the displacement was. So let's do a triangle, 1/2 times base times height. The base is 1, the height is 4. So 1/2 times 1 times 4, this area is 2. 2 feet squared. But we'll get to that. This is just 2 feet because it's accumulation. This right here is the same exact triangle with a base of 1 and a height of 4. But because it's below the x-axis, we're going to say that it has an area of -2. So if I add those two together, what's the displacement? 0. Again, I don't expect you to know that for this unit to be tested. After we learn integrals, we will come back and revisit a lot of stuff with particles in motion and make it cleaner, faster, and more efficient. All right, that's all we have. I believe, yes,